Hi, welcome back to part 4 of the ledge climbing tutorial. And we're going to kick off by implementing a wall slide. If I remember correctly, we left off when it was able to do a wall run and grab onto the ledge. Just to recap quick, so we can do that, and then here we had some strange problems. So we're going to continue. Open your character blueprint. One of the first things I want to do is I want to implement an additional check where we start the trace, the do trace event. So I'm going to create a macro, and we need to call that macro something that makes sense to us to identify. I'm going to call this one can do trace checks. Okay, and then I want to say, is the character falling? And if it is falling, I also want to see, and is it hanging? It is hanging, not. So if it's not hanging and it is falling, or if the character is doing a wall run, then it should continue. Okay, so at the output just add exec, and also at your input add an exec. I'm just going to call this 1 and 1 because I don't need a description. This just needs to be short, so it looks neat and tidy when we do plug it in line. Okay, compile. I'm just going to save everything immediately. Okay, so we need to get that, pull it into this, and make sure that the traces won't fire when that's happening. Okay, and now we need to make some space for some additional checks. So just move this up. Okay, and this stuff I'm going to move a bit this side. I'm going to comment this and just call it checks. Okay, and then we need to, before we do the checks, let's just make sure. Okay, so this roof check I'm going to move up here, so I'm going to plug it out of this section. We did this roof check where it executes the stop wall run, and then when it's not hitting something, it goes to the wall tracer. So I'm going to plug the wall tracer directly into the sequence, and I'm going to slot this roof check in front of some bad stuff has happened. And I'm just going to quickly undo this and make sure that this time nothing's getting in the way. I'm not quite sure why this one's refusing to move. Let's just move it. Okay, cool. Now it's going. Okay, so I'm just going to put this in line, and then from the false here it needs to go to the next check. So it should not. It's very important that you don't plug it in from the stop wall run. This is basically a function by itself, and we want to keep that separate. If you really want to, just to clarify things for yourself, you could essentially break this off into another section and just call this the stop wall run section, which is what it is doing. That might just keep things a bit more organized for you. Okay, this checks we're going to expand on in this section of the tutorial, but first I think we should do a wall slide. So after this wall tracer that we are doing here, we're going to continue from this, and we're going to create the wall tracing section. Not the wall tracing section, the wall sliding section. So I'm going to branch out, and we're going to need a macro here. Now before we do that, let's just complete what we are doing. Do once and create a custom event and call it wall sliding. Create another custom event and call it slide stop, or to be more descriptive, wall slide stop. Okay, so this do once is going to fire the wall sliding section. Okay, and this section is going to, actually let's create another custom event here. I'm going to call this reset and stop wall slide. So this doesn't actually just stop the wall slide, but it resets it so that it can do another wall slide when it needs to. So that just plugs into the reset. But we're going to need to do more than one thing with this custom event when it gets fired. So I'm just going to add a sequence there, and it needs to not only reset, but it needs to actually now fire this wall stop slide we created. So I'm just going to wall stop, or wall space stop. There should be a wall slide stop. There we go. Wall slide stop is then being fired. Just moving this out and commenting this to can do ledge slides. Now we still need to create the macro here for what the conditions are going to be in order to do the wall sliding. So let's create a macro, and I'm going to call it can do wall slide. Okay, and from that we're going to have quite a few conditions that needs to be false in order for this to go through. So first let's get the velocity of the actor. Did I spell something wrong? Get velocity. Oh, there it is, get velocity. Okay, and we want the break, break this out, because we just want the z value, and then we're going to check less. Let's make it less. So if it's less than 300 minus 350, then that is one of the conditions. Okay, and another condition we want to say is it wall running? Get, is it hanging? Is it climbing a ledge? And I think we might have to make some leeway for something else here. So let's just quickly say not. Let's create another bool and call it is sliding, because that's what we will be doing just now. We're going to be implementing the sliding, so I want to see if it's sliding or not. None of these should be true, so I'm just going to say not, and then plug it in a few times. Now, originally I don't have any coding background, so I'm not always familiar with how coding works exactly, but one thing I do not understand is that I would have assumed you could have said or, so is this, or this, or this, or this, and then just have one not node at the end. So whatever that might be, and there's a not behind it, then technically it should still return the not, but I don't know, that doesn't work. Well, in my blueprints, it doesn't work. If I do it that way, it just constantly returns as true. So maybe it's just because I do not understand logic or the way code works, but I would have assumed that should have worked. But yeah, like I said, I don't have any coding background. Okay, so once you have those, we just need one more check, and we're going to get the actor location, and we want to minus it with another vector, and that other vector will be the wall trace impact. So that is where the wall got hit. So we're basically going to get the distance between where the actor is and where the wall was hit during the trace, and we want to get the length, get vector length. Now we have the distance in a nice float value, and I want to say less than. So if that distance is less than what we want it to be, which we'll specify. So drag your input close to here and create a float. and on the float then call it distance, okay, and plug that in there so we can manually specify it on the macro, just to make workflow a bit easier if we do need to tweak some settings. Okay, and then at the output we just need a bool value, and I'm just going to call this is, so it's nice and clean and short. Okay, and then we can compile and save. So we're doing these condition checks and can do wall slide. We're then plugging in there. Now we need to think about the distance. It needs to be relatively close in order to do the wall slide. So it needs to be almost right up against it. But I'm going to make it 80 because your capsule is pushing it away from the wall as well. And if I remember, actually I don't remember, our capsule is how big? So that's 42 units, so 80 should be good. Okay, so now we're going to actually create the wall slide setup. So those were just the conditions to check if we can create the wall slide or do the wall slide. First order of business is to go to the blueprint interface we created and create a new function. This function we can call, don't call it ledge slide, call it wall sliding underscore bi. Okay, I am going to create, actually I'm not even going to create a bool value. I just want to fire an event off to the animation blueprint. So I'm not gonna bother with setting bools and stuff. So we need to get the anim instance, and then from the anim instance we need to tell it that it needs to run that wall sliding message. Okay, well, it needs to send the message. Okay, and then we created this is sliding bool value just now in the macro there. So we're going to set this. We're going to set this to true, and then wall slide stop we'll just leave there. Actually we're going to use it right now, and what we're going to do is, what we can do, we can just copy and paste this, okay, and plug it in. Just want to make sure the stuff is the right distances. Okay, and this time when it stops we're going to tell it to be false. Okay, so we're going to create a timeline now. So add a timeline. Now the timeline is just going to be used to constantly fire that while it needs to. So I'm going to call it sliding time, and when it stops it needs to stop the timeline, and when it runs it needs to play it from the start. So the reason we're doing it via the timeline is because effectively this is only going to fire once here, and then when it does fire once the slide still needs to constantly do what we need it to do, which would be to actually push the character or launch the character. Just open the timeline and then tick loop so that it never stops unless we tell it to stop. Okay, so it's looped now. So the next thing, we're going to launch the character. Now launch the character basically pushes the character into a direction, and we need a variable. You can set it manually just here, but I'm going to create a variable and I'm going to call it sliding speed. Change it to a vector. Okay, and then just drag this in here, get it, make sure it's plugged in there. I'm going to compile and save quick. Okay, so one other thing that's important to remember is that on your launch character you'll notice Z override. Basically what that does is it overrides your current Z velocity. If you don't tick it, it's going to add this velocity that you specified in here, which we did not. We'll do that now. It's going to override, if you tick it, it's going to override the velocity. If you don't tick it, it's going to add to your velocity. We we don't want that. We want to override the velocity so we can control the speed ourselves. So I'm going to make the z value minus 180 because I want him to slide downwards at a minus 180 speed units. Not sure how you phrase that, but yes, that's basically what is happening. We're going to run out of space there. So I'm just quickly going to drag this and move this up a little bit. And then we need to do a trace, sphere trace. I'm going to type single sphere trace by channel. Okay, now we can use the exact same macros we created earlier, which was the wall tracer. We created the wall tracer. There is one thing that we do need to modify within this macro, and before we modify it, let's just quickly plug this into the start and the end. Change your radius to 20 and visibility channel. Let me just think, okay, for now we're going to change it back to ledge trace, and actors to ignore, we can just say make array again, and the array is empty, so it's not really ignoring anything, but that's the only thing that'll block it. Okay, so open up this wall trace. Wait, don't use wall tracer. I apologize. What we are doing is we're doing the sliding, so we need to actually check when does it need to stop doing the slide now. So I'm going to remove that macro, and we're going to create a new macro, and I'm going to call this the floor distance, because that is what we're busy doing. We're busy creating the sliding, and what this channel trace is going to do, it's going to check when this character is on the floor, and once it's on the floor or a certain height from the floor, it'll stop doing the slide. Otherwise it's just going to slide down, hit the ground, and think it needs to keep sliding, and we don't want that. So just open up that macro and then select the input, create a float, and from there we'll just call it distance, or maybe call it height. That's more clear of what it's going to be used for. Okay, so let's get the actor location, and then the forward vector. Get the forward vector. Okay, I've noticed this though, there's two forward vectors. There's the get forward vector and the get actor forward vector. So get the forward x vector length from this actor in world space, and this one is rotate the world forward vector by the given rotation. So I think this does exactly the same thing. So we can just use that, and we're going to add the two together. Why did it do that? Plus another vector. Okay, so we're adding those two, and then we are going to break it up. Okay, and we're going to make vector. Okay, so slot that in there, and then bring your input over here, and we're going to have a minus. There we go, and plug that in, and this goes in here. Okay, and on our output we need to have two vectors, the start and the end of the trace. So I'm just going to call this start and end. Okay, and I think this one should be the end, because we're going to do the minus there, and from the plus that'll be our start. Excellent. This line is not aligning. Man. Oh well, there's nothing I can do about that. So now that we do have those distances, we can just close this macro and bring it in here to get the floor distance. Okay, and let's make it, how high do we need to be? Maybe 180 units. That is quite high. Maybe 120. Let's make it 120. Okay, so if it's 120 units above the ground, so it's going to stop sliding the moment it reaches that height from the ground. So we need to complete this. I'm going to branch out from the trace. Okay, and then I'm going to have from the false, I'm going to reset a do once, because I only want the do once. This needs to reset it. Only one, we already ran out of space here. How is that even possible? Why is this graph so long? We can't really make it much shorter. Make it a little bit shorter, but not much. Okay, and from here we are going to reset and stop the wall slide. And we'll just quickly run through this again, but before we do, there needs to be another condition here. So I'm going to branch again, and we want to say, is it sliding? And then if it is sliding, it needs to do this. And if it's not, it needs to reset it. Okay, so just to quickly run over what we did is, we created the checks to see should it start the wall slide or should it stop the wall slide. And stopping the wall slide happens at the end of this. It does that. So effectively, when it starts, it's calling the animation, telling it to do its thing, setting this bool, and then the timeline is just constantly firing our character, moving our character in the sliding direction. So I'm just going to comment that quick there. And then it does a trace to see if character is near floor. So when he is near the floor, he's going to stop doing his slide, and that's why we're checking. So it's checking, is this false? I'm not hitting anything. Okay, cool, then don't do anything. Oh wait, I am hitting something. Am I busy sliding? Yes, I am busy sliding. Then cool, awesome, do this, do the reset. And then when it runs the reset, it basically tells it, okay, I can do another slide, but I must stop now doing my slide. So that's how that works. And I'm going to comment this, and I'm going to call it wall sliding section. Okay, and that should take care of the basic functionality of that. I really don't like what's happening with the graphs here. I'm going to move this up for now, and then just bring this up. Yeah, that looks better. Okay, cool. Now we need to go to our blueprint. So animation blueprint. I just open that up, and then the sliding needs to be montage. So I don't have it in my project, and don't know if you've downloaded it. I hope so. If not, download it. If you have your own sliding animation, awesome. And also, let me just quickly import this placeholder. Where did I put it? I think I put it on my art files. Slide placeholder, and there we go. Okay, so it's not an animation, it's just a frame of a pose he's doing there. Okay, and then let's go back to the blueprint, animation blueprint. It's going to be a state. So in order to control the state, we'll need a bool. Let's go to the event graph under this section here. We need to make an adjustment though. I think I was a bit over rushing this too much. Go back to your interface, blueprint interface, and then select the wall sliding and just add a bool value there and call it is sliding underscore bi. Okay, because we are actually controlling a value there. So we'll get the sliding bi being fired, and this is going to change our blueprint here as well for our character. On the sliding logic we created, now we need to tell it, okay, so if it is doing wall sliding, tell it that it's true. If it's stopping the wall sliding, tell it that it's false. So that is good that we did that now. and I'm going to right click and promote this to a variable, and I'm going to name it is sliding. Okay, so now we do have that bool there. So let's go to the state machine. I'm not sure what you call this. It is a state machine, yes. Okay, so we only want to do the sliding from the jump start and the jump loop. We don't want you to do it from the ledge grab or stuff like that, because ledge grab can in any case only go back to jump loop, so it will reach that. So let's create a new state and call this sliding, or you can call it wall sliding if you prefer. So those two needs to reach it, and this one needs to be able to transition back to jump loop. So first open this up, and then let's get the animation slide placeholder, and that's the one we will be playing. And we want to make sure that it can only enter this transition if sliding is true. I'm going to copy this, and then it should be able to enter this transition the same if it's true, and then it should only be able to exit from sliding if it's not true. So if it's no longer set to sliding, then it'll do that. So we can quickly just run this and see if we missed anything and if the sliding stuff is working. And I'm thinking I should maybe change that to visibility, because the one thing that this is doing, it's tracing. We don't want it on the ledge trace channel. Majority of stuff has got visibility blocked on the trace channels, and because we're doing a slide, we don't necessarily need to check for one specific object. We can leave it on visibility, so the moment it's blocked by anything, basically it's going to stop. And then also I just want to see, okay, so here we are doing a ledge trace and not a visibility, and the reason I'm doing that is because I'm just segregating the tasks so that we don't end up in a position where it's trying to do a wall slide against enemy's face and then gets killed. We don't want that. We want him to only go to walls and stuff. But I am using similar methods for melee takedowns or melee takedowns. Yeah, that's the principle. In any case, we need a testing platform here. So I'm just going to take this one and move it. I'm going to make it quite big as well, so that I can definitely always slide on that surface. Okay, let's just see. Okay, it didn't actually go into the slide phase, and you did notice, you probably saw this now, where it did that. It's rotating in the wrong direction. Okay, let's just see what's happening here. Okay, so it's not going into sliding at all, and the reason for that is not known yet. We'll check it out quick. Okay, I think the reason for that is because I made a mistake here, and hopefully you picked it up. I didn't. I missed this completely. After the do once on the can do ledge slides section, I executed wall slide stop. Wall slide stop should get run from here, not from there. That should be this one, wall sliding. So I just added the wrong one there, and it would never actually go into a wall sliding. So that was luckily easy fix. Okay, there, it did go into it. So let's just climb up here, and we'll fix that rotation problem just now. Okay, so there, it is doing the slide. Okay, so we can improve it a little, but for this we're not going to. And what I mean by improve it a little is actually make it not being able to rotate, or when it does rotate away from the wall, it lets go of the wall. That's basically what we want. Let's fix the rotation problem quick. So that rotation is happening when it's moving to that location. And that's happened during the wall run. So we need to find the wall run section. There's the grab ledge and then the wall run logic. Here we go. Okay, so there should be a block here where it moves the component to. There we go, move component to. So the way we calculate this align to wall, let's have a look at that. Wall trace impact. Okay, so we're doing it this way. And I saw on the forums this one guy did it, Alex. He's got a ledge climbing system. It's quite good, I must say. And he's doing it a bit differently. So we're going to do it that way because it does make more sense, and it's definitely more consistent than what we're doing now. Because what we're doing now is if your actor is, for example, sitting over here and your wall is sitting over here and there's this tiny little angle between them, it's not going to be the direction necessarily that the wall is facing in of the wall's normal. So before we do fix this, we're just going to go back here, and effectively we want to get this impact normal. That's where the wall, well, that's the wall's normal. So we want to get this promoted to a variable, and I'm going to call it wall normal. Wall normal. Why is it not renaming to wall normal? Oh, you know why? Because delete that one and delete this one as well. I think we did it in a trace here. There we go. We did it in a trace. So we are getting this impact point for that, and we are setting the wall normal, but we're not using it in our logic because we have that wall normal. I'm going to set it here as well. So if this one fires after that one, it should use this one, and make sure you take the impact normal and plug it in there. Okay, now let's update this macro of how we do it, and I'll explain to you why this is better. Okay, so the first thing we need to do is we need to actually get the wall normal, and then we need to get we need to break this. I'm not going to break this. I'm going to get the creator XZ. So I'm going to make a rotation from the X and Z value. Okay, and that's going to go in there. This stuff I'm going to delete. So let's get the capsule component and get its up vector. And effectively it's going to extract the Z from this and get the X from the wall normal. And there's one problem. Currently the normal is facing outwards, so if you're looking at the wall, it's facing in this direction, so it's going this way, and your character is basically going to look away from the wall. So we're just going to invert that quickly by multiplying it. Multiply, because it's only extracting the vector, but let's be safe and just do that -1 and get the -1 there. Okay, and that's the value we want. Sorry, I know it's annoying that I can't leave my stuff untidy. Well, it annoys me. Sure, it annoys you. OCD. Let's continue. So now we have a new way of doing that. So let's just quickly have a look here and see what's happening. If it's doing a little, still doing weird stuff. Not yet. Okay. Okay, so that is another issue we'll get around to. But for now, most of the stuff is working. Okay, so we're going to now do the rest of the climbing. So this is just actually grabbing the ledge. Now we need one that does the climbing. What is this? Let go of ledge. Okay, that's fine. That's just letting go of the ledge. I'm going to select this and move this somewhere else because this is going to be in the way. I don't know where's a good place to put it. Maybe here. Let's just move it up a tiny bit so we don't run out of space. Just trying to see. Okay. So first order of business before we do the ledge grab is we need to do some additional checks. And what we are going to do is we want to check wall, the Boolean value. So get is wall running. So it must not be true. Okay, and if that is not true, so if that is not true, we're going to branch, and we can put the branch here. Let's just move this up. Okay, so it's going to go in here and it's going to do the branch. And I don't know if you remember, but we had to do once here initially before everything, and it would only fire once. But now we can actually put it back, make sure it doesn't constantly fire. So just I'm just gonna disconnect this one. Okay, we need another check here, and what this is going to do is some other amazing stuff. Okay, we'll need no, we have the macro. Okay, so that's the distance. We're gonna get that. So if it is not wall running, it's gonna check if what's the distance of the hip, and then if that is true, it's gonna fire this. So if it is in fact wall running, we want to run a sequence here. And this sequence is, firstly, it's going to reset the do ones. Also, if it fails here as well, that it's not in position, in the correct distance, we want to reset that again. So we're just going to sequence that. And effectively, this sequence is going to go to the next state. So I'm just going to say going to next climb action. Okay, so that's what that is used for. We can move this a little. Okay, so this is going to go down to the branch that's going to start our knee climb. We'll call it knee climb, and we're going to have a macro running here, and this macro is going to control quite a few things for us. So let's create a macro and call it can climb knees. Okay, and on the input, create 4 new floats. I'm just going to first change it to float, that way the subsequent ones are floats as well. And then we're going to change this to fall minimum, fall maximum, jump minimum, and jump maximum. Okay, get the hip socket location. I want to get the location, and break this. And we also want to get the ledge height and break it. And we want to compare the two Z values to each other. I'll get the distance between them. So just get the distance between them by doing that. There's another way. We could have worked out the vector length and broke that to get the vector length, but yeah, we did it this way now. So let's do it in range. Okay, and the value that it needs to check is this value, and fall minimum and fall maximum needs to go into those values. I'm going to copy and paste this, and jump minimum and jump maximum needs to go in there, and we're going to compare it with that one again. I don't think there's a way to make this look neat. Okay, and then we want to select select it when it's false, and select this one when it's true, and we're going to look if the character is actually actively busy moving upwards. So we're going to get the velocity, break it, Okay, and then check if it's greater than. So if it's greater than 0, it'll mean it is actively busy moving up. So this can be applicable to the wall running or busy jumping upwards. And that can just plug into the output then. So you can create a bool. I'm going to call it out. Okay, save. So we've got that macro now, and we can pull it in there. Can climb knees. And for now, we'll leave the values empty. Okay, let's move on to the next block. We're going to do another check or another branch event. And on this one, we're immediately going to a select. And we want to make the first one false. And that needs to be is wall running. Is wall running. And we need a tiny little macro here that we can, I don't even know if it's necessary. We can just get the capsule component. I just want to see one thing quick. Get up vector. Get the Z up unit direction. So that's just the direction. So we are going to get the velocity instead. Get component velocity. I'm going to break it so we can get the Z value. And my bad, that needs to be less than 300. Okay, so it's going to check if it's wall running. If it is not wall running, it won't get past this branch. If it is wall running, it also it's first going to check, okay, is this happening? Is the component busy moving up and is quite going up less than 300? So it's not going up too quickly. So if it's the start of a jump, it won't just immediately pop through. I'm going to do another branch. And the reason I'm splitting the branches so much here is just mainly for debugging purposes. You can probably combine all of these together, but I like to see where it's failing, what check is not working correctly. It's just to make my life a little bit easier when troubleshooting. And here I want to check if it's not sliding. Okay, so if it's not sliding, then it'll pass this one as well. Okay, and I only want to do it once. Okay, but now we need to reset this to once, so it can happen more than once. So we're almost going to be using the same methodology. That's is it methodology or methodology? There is a word for that. Any case, we're going to basically use the same method. Maybe I was looking for the word method. We're going to use the same method that we used there. Well, very similar to that. So we're going to run a sequence, and this sequence will go to the next block. Go to next climbing section or function. It makes a little bit more sense. Okay, and if it fails there, it also needs to go into that, and that then resets this so that it can do it more than once. So this block will actually then go down and control your next one, like your feet climb. Okay, after the do once, I'm just going to add one more redundancy check to make sure everything is happening the way it should. And I want to say, is it climbing? Get is climbing, not true. And then if it is, we're going to do the stuff. So go to your blueprint interface and create a new one. Call this, what are we going to call it? Climbing knees underscore BI. Excuse me. In this instance, we really do not need a Boolean value. So we can just literally leave it like that. Yo, almost thought I had a crash there. Okay, so let's get the anim instance. Okay, and then tell it that the knee message, send the knee message over there. Okay, and then is climbing. We want to set to true. Set is climbing ledge to true. And we've officially run out of space with this wall run block here. So let's just find a new home for it. It can move to the bottom there. Okay. And this actually needs to move up just a tiny bit. Okay. We're going to set the movement, set movement mode to flying again. And then we're going to move the component to the location it needs to be at. Move to component location. Why is it impossible to find this thing? It's really getting to me. Move component to. Good Lord. So yeah, now I have to go through this massive list just to find it. It has to be in here. It's really getting to me. Why I can't find it like this. You know. In any case, just get your capsule component. Move component to, you see there it is. So it is there somewhere. Just finding it for me seems to be like finding the unicorn. It's almost impossible, but it is possible. Okay, so we already have these two macros. So the target relative rotation would be the align to wall one that we worked out previously. So you can just plug that macro in there. And then the relative rotation, we have the wall go to location. That rhymed. Except this is going to be different. We'll get back to that just now, and after this I'm gonna stop the movement immediately. Okay, there we go. Nice. Okay, so previously when we used this location here, sorry, I was just checking that it's recording. Where did we use it? On the grab, I believe. So the grab is just above it. So we made this 100 so that it was a little bit below it, because if I remember that thing minuses the z value. Height offset, that's correct. Okay. So we want it to be not so far below. We actually want it to be a bit above it, because your hips are going to be above the ledge. And this is also determined on what animation you are using. In our case, I didn't create a placeholder for this. So I'm going to make it minus 25 so that it's 25 units above the ledge. Okay, and then let's go to the animation blueprint quick. So in the animation blueprint, we can get that event for the climbing knees BI. And we want to check if the montage is playing. And we want to see if it's busy doing the wall run montage. So we'll branch from this if it is in fact doing the wall run montage. If it is, we want to stop it. So let's just stop that montage, the wall run one. And then if it is false, it needs to play the knee montage. But just move this up because we need to plug this in here as well. So it's going to stop it and then play it, or it's just going to play it. And we need to update variables. So let's do wall running, set wall running to false, because it should stop doing that, and then set the ledge grab, set grab, can grab to true. And now we actually need the animation. I didn't create one. I don't know if I just said this or not, but I didn't create one. So I'm going to go to the animations, and we have this climb ledge placeholder here. I'm just going to do this for this tutorial. Duplicate it. So right click that and not the montage. Make sure it's animation sequence. Duplicate it. Just call it knee placeholder. Open it up. Pause it. Okay, first thing is temporarily disable enable root motion. Okay, so we want it when the knee is there. Okay, so the knee is there. So basically then once it's there, right click on it and say remove frame 0 to 25 or 24, whatever the case may be. So it's just going to play that. So it's going to look damn weird. It's not going to look cool at all. But this is just for demonstration purposes right now. Okay, so now that we do have that, just close it up quick, and then go back to it in the content browser, right click, create animation montage. Gonna leave the name the same. Just gonna pause this, make sure the slot is set to the correct one, and we're gonna create an animation notify. Add anim notify, new notify. I'm just gonna call this climb knee end. Select it and make sure under event it's set to branching point. Now we can go to the blueprint, the animation blueprint. We want to get this knee end notification that we just created, and then when we do get it, we want to tell its owner, try get owner. We want to tell it that it needs to stop now because it reached the end. So just call that blueprint interface message and plug it in. Also stop the montage. Make sure it's a placeholder, and just remember to add montage play, set the knee placeholder one. Okay, and then let's set is climbing. We're setting to false, and can grab we're setting to false as well. I just want to check something. I don't think this should be, oh, we do need to set wall running. Okay, so that should be good then. My question is just, why are we setting is climbing here? I know there's a reason I did it. Where is it being set though? Is climbing is being set when event. Okay, for now leave it like that. It's just a redundancy check to make sure that it's not accidentally still switched on when it goes over to that mode. Okay, so effectively now when we do play it, it shouldn't actually work yet because we never filled in the values here on the character blueprint in the knee climbing section. I'm just quickly going to check here. It's super long. I would have liked to make it shorter, but knee climb section. Okay, so we have that now, and we need to fill in these values. So these values are dependent on what's happening. So add a breakpoint here, because this is dependent on the animation that is in fact playing. Just add a breakpoint there and then play it. We're gonna run up this thing. Okay, so it immediately goes there. So open up this macro and look at what this value is. This value should return something. Why am I not getting information? Or maybe it's still just oh, I think it's because this was never connected. Let's just connect that up. Okay, 20th time lucky, they say. And I guess that's not true. Okay, wait, I'm starting to see some stuff here finally. Okay, so check here. Well, where's my screen? Now something is not well. Stop this. I'm gonna play in the viewport so I can switch between the viewport and that. Okay, now let's go back to the viewport. So if you look at the viewport, his hip is there, the ledge is there. So we want to see what the current value is, and that is currently minus 29. So currently minus 29 units is there. Then he shouldn't actually be doing a knee climb. So I would say another 20 units. So maybe if he's at 0, it should be good. And that is how I'm going to determine what these values needs to be. And technically should do the right thing. Just 1 second. I want to check one other thing. I want to check which one it's busy returning. So this is currently to true, meaning it's selecting these values, which are the jump, minimum and maximum. So let's go back and then modify this to 0. And if it's a little bit above it as well, we want it to be able to go into the knees. So I'm going to break this, not break it, I'm going to disable this breakpoint. Okay, I'm going to add another breakpoint here. Oh, let's create another breakpoint here and see if it, excuse me, if it gets there. Okay, so it is actually going in here, and this is currently to true, so it is going to do the ledge grab with its knees, or the knee climb, whatever we want to call that. So let's disable it and then see if it's running. Okay, so it did do it. Or at least it did try to do it. And I think the reason that is because on our knee montage placeholder, did we re-enable the root motion? We did actually re-enable the root motion. So we just need to confirm quickly what we are doing. Is that we are doing this, we're telling the animation to do that, and then we're going into is the climbing ledge? Yes, we are setting into flying, and then we are moving the component to the correct location to do the actual animation. So I'm going to make this a little bit higher, so it goes to location just a little bit above, and it's still doing some weird stuff, and now it's just flying and actually stop climbing. So I'm going to pull this section out from the ledge climbing section as event climbing ledge BI, so you can search for that and you should find it. I'm not going to copy it, I'm actually literally just going to pull it out of there, move it sideways, and then we have that knee interface that we created, event climbing knees BI. This I'm going to take off from there. We need to make sure that is set to false. And these two, both of them, because they're doing the same thing, I thought it would be a good idea just to put them together. And let's say you implement the feet climb. You want to do it here, do the stop, just plug it in here as well. and I'm going to comment this section and call it stop climbs. My eye keeps twitching terribly. Okay, and I can move this back in here then. I'm pretty sure it's not going to work just yet, because that didn't look like it was not stopping. It just looked like it wasn't getting anywhere. Okay, actually now it did work. Okay, so as you can see, because we have that weird animation and not a nice one, it does look a bit dodgy. It doesn't always get where it needs to go. But I think let's call it a night, and this will then conclude part 4, and then in part 5 we'll just refine this, and hopefully in part 5 I would have created the final animations for this, and we can then make everything look nice and pretty as well, and then also troubleshoot any other problems. Okay, cool. Thanks for watching, guys. Cheers.